Data is everywhere, but with great data comes great responsibility. The responsibility to ensure its accuracy, consistency, and integrity. This is where SQL constraints come in, powerful tools that act like data guardians in your database. Just like traffic laws keep our roads safe and organized, constraints are essential for maintaining the health and integrity of your database. In this episode, we'll explore what constraints are, their significance in data management, and provide real world examples to illustrate their power. Let's get to it. What are the different types of SQL constraints? First one, primary key constraint. We learned about primary keys in our previous episodes. They are unique identifiers for each row in a table. The primary key constraint enforces this uniqueness, ensuring no two rows have the same values for the primary key. Why is it important? Primary key constraints are essential for efficient data retrieval and maintaining the integrity of your database. Without them, duplicate data could lead to confusion and inaccurate results. Let's take an example. In a customer table, the customer ID column can be set as the primary key by defining it as the primary key constraint. This ensures each customer has a unique identifier, allowing for quick retrieval of specific customer information. Next, not null constraint. Imagine a library card with a missing name. The not null constraint prevents null values from being entered in specific columns, ensuring critical data is always present. Why is this important? Not null constraints guarantee that crucial information is always available. This prevents missing data that could hinder analysis or functionality. For instance, in a customer table, you might set a not null constraint on columns like customer name and email to ensure the essential customer information is always provided. Next one, unique constraint. When a primary key can only exist once per table, a unique constraint can apply to any column or group of columns. It ensures no duplicate value exists for a specific columns within the table. Then what is the difference between primary key and unique constraints as both sounds the same? The key difference is unique constraints allows null values while primary key constraint doesn't allow nulls. In other words, unique plus not null constraints is equal to your primary key constraint. Why it's important? Unique constraints help prevent data redundancy and ensure the validity of specific data points within a table. Example, in an order table, you might set a unique constraint on a combination of order ID and order date to ensure no duplicate orders are accidentally created within the same ID and date. Check constraint. Sometimes you need more control over the type of data allowed. A check constraint allows you to define a specific condition that data in a column must meet to be valid. For example, you can ensure an age column only accepts values greater than 18. Why it's important? Check constraint provides an extra layer of validation, ensuring data adheres to specific business rules or data quality standards. This can help prevent invalid entries that could skew analysis. Example, in a customer table, you can add a check constraint on the age column to ensure age is greater than 18. This enforces the business rule that only customers above 18 can be registered in the system. Next one, foreign key constraint. We also explored foreign keys in our previous episodes. They establish relationships between tables. The foreign key constraint enforces referential integrity, ensuring that values in a foreign key column actually exist in the reference table's primary key. This prevents orphaned data and maintains consistency across linked tables. Why it's important? Foreign key constraints are crucial for maintaining data relationships between tables. They prevent inconsistencies and ensure data accuracy across your database. Example: in an order table, the customer ID column can be a foreign key that references the customer ID primary key in your customer table. The foreign key constraint ensures that every order listed has a corresponding customer in the system, preventing orphaned orders. Last but not least, default constraint. A default constraint defines a default value that will be automatically inserted into a column if no value is explicitly specified during data insertion. This helps ensure data consistency and reduces the need to manually enter repetitive values. If you recollect the example we discussed for the not null constraint, that is missing name on a library card. One way to prevent null values is by defining a not null constraint. And the other way is to define the column with a default constraint, which can be used as well to automatically populate a column with a specific value if no value is provided during data insertion. Why it's important? Default values save time by automatically populating columns, improving data entry efficiency. By ensuring certain columns always have a value, default constraints promote consistent data across the database. One quick example: you can set a default value of active for a customer status column, ensuring new customers are automatically marked as active unless otherwise specified. Now that you have tamed the power of SQL constraints, your data is a well oiled machine to ensure your database remains healthy and organized. So, constrain your data and unleash its power. Stay tuned for the next episode.